When graphing rational functions, there are many properties that we could look at. However, we're just going to focus on a few features so that we get to understand the basic idea of rational functions. And again, we'll get more in depth in this as we get into grade 12, into calculus. But we're just going to look at a few key features, and it's going to start giving us a picture of what we're looking at. It's not going to give us necessarily the complete picture, but it'll start giving us pieces that we can work with to start developing a picture. So a rational function is anything that can be written where we have m of x over n of x, and the m and n represent polynomial functions, and the n can't be equal to 0, because if n is equal to 0, then we'll end up dividing by 0, which we know we can't do. So there's a couple things that we should know, the terminology. There's something called an asymptote. An asymptote is a line that the curve approaches that never touches. So in this case here, if I kind of see along this x-axis, the x-axis happens to be a horizontal asymptote of this red graph because it just goes closer and closer to that line, but actually will never touch that line. Okay, so it doesn't touch that line. So it just approaches the value of that line as we go out to infinity. So this is something that we call endpoint behavior. So this is an example of a rational function. Okay, and again, to know what this looks like, we're going to have to start looking at a few features of this algebraically to be able to translate that into physical features on the graph. This graph here has what we call a vertical asymptote. The green lines, dotted lines, represent vertical asymptotes. They're actually an imaginary line that the graph goes closer and closer towards, but never touches. And those happen to be generated by this denominator, where the denominator is equal to 0. Because where the denominator is equal to 0, we cannot let that happen. So we end up with a restricted value, and this shows up as a vertical asymptote. So the denominator not being equal to 0 is a key feature of a rational function, but here at x equals -2, we know we have a restriction here. And if we take a look at the table of values at -2, yeah, there's a restricted value, there's an error. But how it shows up in this case is it shows up as a whole. So in this case, the divide by 0 positions end up as vertical asymptotes. Here, the divide by 0, -2, ends up as a whole. So these are some key features that we're going to start looking at. There's vertical asymptotes and wholes, and these are related to restrictions on x in the denominator. These are non-permissible values. So when we looked at non-permissible values, this is one of the reasons why we needed to have these to be able to locate or identify these non-permissible values, because something is happening there on the graphs. And these are called local behavior because this is what's happening locally. So locally here there's a hole. Locally here at x equals -3 and +3, there are these vertical asymptotes. There are also horizontal asymptotes, and these are what we call endpoint behavior. And what's happening to y as we get closer and closer to the infinity. So if we take a look at these ones here, there's a horizontal asymptote here. This imaginary line that as we go out to infinity, it just gets closer and closer and closer to that value. It gets closer and closer to 0.